All right, so previously we talked about what a square root is, what a radical is, and we talked about estimating about how much it is as a decimal, okay? What we're gonna do today is we're gonna talk about how we can take a radical and simplify it. Okay, so just like there's different things that you can do with fractions, right? Like you can know that 1/2 is the same as zero point 0.5, right? That's kind of what we already did. And what we're gonna do today is kind of like knowing that 2/4 is the same as 1/2. Okay, so they're both useful skills. All right, this one's going to be just something a little bit different. So we're going to talk about simplifying radicals, just like kind of how you simplify a fraction. And we're going to use something that I call the birthday cake method. Okay, so the birthday cake method, you're going to see why we call it that in just a minute. But basically, here's what you do for the birthday cake method. Okay, you are going to take the inside number. Okay, so the 27, the 20, the 50. On this one would be the 32. So you take that inside number, the number inside the radical, all right, and you're going to divide that by prime numbers, okay, until we get to 1. Okay, so we're going to divide it by prime numbers until we get to 1. All right, now what's a prime number? Prime numbers are numbers that don't divide any smaller. Okay, so like as an example, 3 is prime because there aren't any numbers that evenly go into 3 other than 1, but that doesn't really count. Okay, so 3 would be prime, but like 4 isn't prime because 2 divides into 4. Okay, so prime numbers are numbers that don't break down anymore. So let's skip this for right now and make our list of prime numbers. Okay, so our list of prime numbers, 1 doesn't count because 1 technically goes into everything, but when you divide by 1, it doesn't actually change anything. So we don't count that one. Okay, so our first prime number is going to be 2. Okay, the next one's 3. 4 is not prime because 2 goes into it, so we skip that one. Okay, 5 is prime. 6 is not prime because 2 or 3 will divide into 6, so we skip that one. Okay, 7's prime. 8's not prime because 2 and 4 divide into it, so we skip that one. 9 isn't prime because 3 goes into it, so we're going to skip that one. 10's not prime because 5 and 2 go into it, so we skip that one. 11, though, that's prime. 12, that's not prime because 2 or 6 will go into it. The next one, 13. 13 is prime. Okay. And then after that, I think the next one's 17. It's not true. I don't think I know. The next one's 17. Okay, so those are our first few prime numbers. So they're numbers that don't divide into anything smaller. Okay, so what we're going to do is we're going to divide the inside number by those prime numbers, those numbers in that list. Now, they do technically keep going on. That's why I put the dot, dot, dot there. There's technically an infinite number of prime numbers. But for this class, you're not going to need anything bigger than this. It'll be pretty rare that you even need like 13 and 17. Mostly it's going to be these first few. All right, so that's going to be our thing. Now, if you have a number in front, a coefficient like that 3 there, okay, basically what we're going to do is we're going to ignore that until the end, and then we'll take care of it at the very end by multiplying it back in, okay? So you are going to ignore any coefficients. So ignore any coefficients, and if you don't remember what coefficient means, you might want to make a note to yourself. It means the number in front. Okay, so you ignore any coefficients, and then at the end, we'll multiply by them. All right, so now let's start taking a look at these, and we're going to start breaking them down. Okay, so this guy right here, we're going to use this birthday cake method. Now, birthday cakes, they're a little bit different than most of the time. Most of the time when we do math, you start at the top and go down. Birthday cakes are a little bit different. You start at the bottom and you go up. Okay, so I'm going to give myself a little bit of space, and I'm going to start down here with the 27. All right, and here's what we're gonna do. You know those like fancy tiered birthday cakes that they make for like wedding cakes or like really big fancy parties? Like in Sleeping Beauty, when they're making the cake, it's got all the different tiers. That's what this is gonna kind of look like, okay? So we're gonna put a little division symbol around that, just like a long division symbol. And then we wanna find any one of these prime numbers that will evenly go into 27, okay? Any one of them. So for this one, 3. 3 will work. 3 goes into 27. So I'm going to put the 3 on the outside. And 27 divided by 3 is 9. So I'm going to put the 9 on top. Okay, so right now it just looks like a regular long division problem. All right, but what we're going to do is now we're going to add another long division symbol around that one. And we're going to do the same thing. Go back to the list, find any one of these numbers that evenly goes into 9. And 3 actually works again. So I'm going to put a 3 here. And then 9 divided by 3 is 3. And now we're going to do it again. Put a long division symbol around that. Find any one of these prime numbers that evenly goes into it, which, hey, 3 works again. It won't always be the same number. 3 divided by 3 is 1. Okay, and then we're going to stop. So you divide by prime numbers until you get to 1. And the way that you can remember that you stop is when you get to the 1 on the top, right? I'm going to put a little flame up here to make it look like a candle. And do you see why we call it the birthday cake method? Doesn't this look like one of those tiered birthday cakes with a candle on top? All right, so there we go. All right, so that's the first part. Now that's the hardest step. That's the part that takes the most time. So now that we've got that, now we're going to figure out, well, what's our actual answer, okay? So from here, what you're going to do is you're going to look at the outside edge. So not these numbers here, but these outside prime numbers that we found, okay? And we're going to look for pairs, okay? Because square roots are asking you what number times itself, right? So we're going to look for pairs of numbers, so a number times itself. So for this guy, I've got a pair of numbers right there. You could have circled these two instead. It wouldn't make a difference. Okay? And then what happens is any number that's in a pair is going to go on the outside of your radical. And any numbers that are left over that aren't part of a pair, like this 3 right here, that is going to stay on the inside of your radical. Okay, so it's sort of like a partner event. If you have a partner, you get to leave and go do the thing, right? But if you don't have a partner, you have to stay behind. All right, but since partners work together, when I write my answer, I'm going to have on the outside not both 3s. You're just going to put 1 3 on the outside to represent the pair. And then the other 3 stays left over on the inside. Okay, and that right there is your answer. Okay, now that one's a little bit tricky to see because they're both 3s. So let's do this again with the next one. And hopefully that'll help a little bit. So square root of 20. So I'm going to start down here with 20. All right, and I want to divide this by any one of these numbers in the list. Okay, so the first thing I notice is 2 works because it's even, right? So I'm going to start with 2. Personally, I always like to do the 2s first if I can. I think that makes it easier. 20 divided by 2 is 10. Okay, and then I'm going to do another layer, and I'm going to look back at my list and find another prime number that goes into 10. Okay, and I notice that it's even, so I'm going to do 2 again. Now, you might have noticed that 5 goes into 10. You could totally use 5 instead. It doesn't matter. You're going to end up with the same numbers at the end no matter what. Okay, 10 divided by 2, that's 5. Okay, and then I'm going to do the same thing. One of these that goes evenly into 5, well, 5, right? And then 5 goes into itself once, and there's the candle on top of my birthday cake, so I know I'm done. Okay, so it's like my little flame. That's what that little thing is supposed to be. All right, so now I'm going to look for pairs, right? So here's a pair of 2s. So the pair goes on the outside, right? And anything left over, that 5 doesn't have a partner, so that's going to stay on the inside. So my answer, I'm going to have just 1 2 on the outside to represent the pair, and then the 5 left over on the inside. And that's it. All right, let's do it with 50. So I'm starting with 50, and I'm looking for any one of these numbers that goes evenly into it, right? So you might notice 2 goes into that. That would work. You might notice 5 goes into 50. That would work too. I think I'm going to go with 5. 50 divided by 5 is 10. All right, and then I need a prime number that goes into 10. 2 will work. And 10 divided by 2 is 5. and then a prime number that goes into 5, 5 goes in. One time, there's the candle on my birthday cake, so I know I'm done. All right, so I'm looking for pairs on the outside. So you see how there's 2 5s? That still counts as a pair. Even though they're kind of split up from each other, they still count as a pair. So that 5 is going to go on the outside, and I'm going to have a square root of 2 left on the inside. And that's my answer. All right, this last guy, this one's a little bit different just because there's a number out front. Okay, but like we said up top, right, we're going to ignore any coefficients and multiply them at the end. So we are going to ignore for now that 3. So we're ignoring that for now. We're going to start with just the 32 like we've been doing. So I'm going to start with my 32, and I need a prime number that goes into that. So I'm noticing that 32 is even, so I can put 2 into that, right? So 32 divided by 2 is 16. That's even, so 2 goes into that. Goes in there 8 times. 8's even, so 2 goes into that 4 times. Ooh, that's even, so 2 goes into that 2 times. This is a really tall one. All right, and then 2 goes into that once. So we had a lot of 2's here. All right, so let's look for pairs. So I got a pair here, but then I actually have another pair here. Okay, and that's all right. So what our final answer is going to be is I'm going to have 2 2's on the outside, and we're going to write that they are multiplied together. So these 2 on the outside come from my 2 pairs. And then left on the inside, right, I'm going to have the one that isn't from a pair. So that was the leftover one. And then one more thing. This is where that 3 is going to come in. So this 3 that we ignored for now he is going to come down here and get multiplied on the outside. Okay, and all we're going to do is just multiply together. Anything that's on the outside gets multiplied together. Anything that's on the inside gets multiplied together. So 3 times 2 times 2 is 12. And then we're going to have that 2 left on the inside. And that's my final answer. Okay, so anything that's on the outside, you multiply together. Anything that's on the inside, multiply together. Okay, and that is how you simplify radicals. We're going to practice this a lot. You'll get really used to this birthday cake method. All right, but it really requires you to just be familiar with some of your multiplication facts. So that's a big thing to make sure you're good with.